Okay, so please tell me, do you hear me now? Stream should be restarted, and I hope you can now hear me. Okay, great. So let's today start a new topic uh, about object-oriented programming. So all the code we have written before, for example, like this, we have put inside main function of some empty class. So that's more about so-called procedural programming, and that's, let's say, a previous century of uh, programming paradigms. Uh, so when we need to write bigger programs, bigger applications that consist of thousands and millions of lines of code, we cannot put it just put in main function of one file. That would be nearly impossible to understand what's happening inside and somehow change the code and so on. So somehow we need to organize our code. Somehow we need to define some logical domains. So the term stands for some thinking about business entities. So what should this application perform with what I don't know, abstractions should be represented inside this code and so on. So uh, in uh, in C language that was popular and was used before Java, there was some um, language allowed to perform to define some structures like blocks of code with variable names, but okay, that was quite a great thing in its time, but Java classes are much more sophisticated and allows much more much better organization of code. So when we're talking about object-oriented programming, it's about so object-oriented. Here it is objects. Uh, Objects are the base of such applications, and objects are created from classes. So today's topic is classes and objects. Uh, so let's start from the first new term, class. So class, it's uh, that's not about school class or class that is used in some classifications. So class of I don't know, some animals and so on. So class in terms of object-oriented programming, it's like a blueprint of objects. So it is a description of objects that will be used inside our application. So actually, I can try to describe everything that is around me with some depth of detailization. For example, here I sit down, and here on a bed lies my cat. So, well, I can try to describe it only by name and color, but okay, I can uh, try to uh, describe him deeply. So he has age, some vaccination passport, chip number, and so on and so on. So this blueprint may be uh, detailizate in several ways, from less details to more details. So in terms of Java, this class, it's description of our objects in terms of state and behavior. So this is uh, two most important terms of this class. So state means some properties of objects that we will use. For example, if I'm describing cat, so name and age, it's and color, so it's a state. So it's some properties, some characteristics about an of particular object. So for example, here's my cat, and there is in I don't know, in neighbor. For example, my neighbors has another cat. So that's still, so I have a cat and they have a cat, but they are two different cats. And for my cat, this state will be so I have a white cat, but they have a black cat, for example. And so this state stands for this characteristics of particular object, but all objects of this class have these characteristics. So every object, so every cat has its color, every cat has its age and name, and so on. And behavior, it's what all objects of this class can perform. For example, every cat can sleep and eat, for example. So before talking about syntax, one more analogy here. For example, you need to swim across a river. You have a blueprint of a boat. You cannot just take this blueprint and try to swim with it across a river. So that's a bad idea. Your blueprint will become wet and will be destroyed. But if you cannot swim, so that's absolutely bad idea to swim with it. It's much better idea to take a blueprint and go to boat master, give him blueprint, give him materials, and after some time you will get a boat. Then you can take a boat and swim across a river. So in these terms, class it's this blueprint, how to you define your boat. Uh, so this boat master, it's a Java virtual machine. Resources will be processor time and memory. So variables that we use usually here, so they are not they are not free. They cost some memory, and objects the same are consisted from variables, so they consume some memory, and object creation takes some processor time. And having this blueprint, your boat master can produce multiple boats, so as much as you have resources. So here it is computer memory. Okay, now let's go to syntax and look how this is represented in Java. First, let's create a new general package here in one hierarchical line with arrays and loop. Let's create one more package called OOP. Next, let's create a new package inside basics. So very similar how we have done previously for loops and arrays. So upper level package called OOP and lower level package called basics. Then create class called zoo. So I know that analogous and examples with cats works better than anything else. And let's create a class called zoo inside these packages. So inside OOP package, let's create package basics, and there a class called zoo with main function inside. Okay, now let's get back to theory and look on syntax, how we define classes. So we will talk about modifiers a little bit later. So our currently used modifier it's public. So just for start, let's start with everything public. So modifier it's about access levels. Next, so public class means that we can use it from everywhere else, from anywhere of our application. Next, here it is keyword class. And next, here it is class name. So how do we name our class? Always from uppercase letter. And these naming conventions for class are very similar to variable naming. So it's always one word. We should not start it with digits. We can use this underscores inside, but better use this camel case. So very similar to naming variables, except uh, we always name class with uppercase. And next we have this well-known curly braces. Actually, we have already done this much times. So when we created new classes inside our application. So here it is example. Public, that's access modifier. Class, that's keyword that is needed to define a class. And zoo, so that's the name of a class. Next, we have opened curly brace, and somewhere in the end of file we have this finishing curly brace. And here inside the class we have fields, constructors, and methods. So that's all. It's about state and behavior. So how we describe our class. So for now, let's create here inside basics package one more class called cat. But in this case without main function. So here inside this package we will have main function only inside class zoo. For all other classes that we will define here today, we do not need main function. So here when we describe this class cat, just only for now only this empty curly braces without main function. Um, I'll tell about this a little bit later about main function. When do we need it, and when do we do not need this? So yeah, not really magic. Okay, now let's try to describe our class. So let's get. So this is uh, the minimal declaration of class. So some access modifiers, class keyword, class name, and curly braces. So that's enough for minimal class. Okay, now let's try to uh, talk about state. So here it is called fields. So today there will be a lot of new terms. So earlier, when, for example, with arrays, so we have used variables, just like this. Int simple is equal to 5. Here we have defined arrays and so on. Just a lot of variables inside. So for describing class fields or state, we do the same. With the only difference, we also use access modifiers. So if I want to that all the cats have name, so I write the same string name, and that's enough for this time. So by this, okay, now let's just it be public everything everywhere here for access modifiers. So by this line, I'm telling that every cat has a name. And by this public access modifier, I say that, okay, that's a public information. Everyone can read and change this name. So this variable, all the variables of a class that are used to describe objects of a class, they are called fields. So here inside the slides, it is called fields. So class state, for example, name, age, and so on, it is called state, class state, and but more technically, it's called fields. So this is synonyms, and and so what happens when we are going to our boat master to our GVM and asking to create a new cat. Uh, so there will be an object placed inside virtual our memory, and there will be reserved uh, a place to store a name of a cat. Now let's create one more variable to describe a cat. Let it be age. So just like this, we can describe object each. So we can here we can describe everything about cats. So we can find and choose some properties to describe each cat. So for example, each cat has a name and its age. Okay, now let's get back to class Zoom. So just for start, please rewrite these two lines. So now when we work with multiple files in same time, we will switch all the time between them. So briefly, it's the same variables that we have used before, just with access modifiers. We are usually writing them in the start of class description. So usually here goes on the class description start we have variables, and only then we have behavior. Okay, now let's go to class zoo, and here in main function, now let's create a new cat. So this is done in similar way that we have used before for variables. So how we have done it before. Int simple is equal to 5. So first we had variable type, then variable name, and value. So similar approach we have when we are creating objects. So this variable name will be the same as class name. Next, we have a variable name, and here comes new keyword new, and again class name. So here it is how we created a new class object. So here's the difference between class and object. So class, it's a description of objects that can be done from this class. Objects, it's a place in memory that contains state for particular objects. So we have only one class called cat that describes all the cats we are using inside our application. So look, we have created one cat with and named it Prince, and here it is another cat called Murinch. So these two are just variable names. So please rewrite these two examples of how do we create objects. Oh, what's that? Okay, it is. Okay, I see that it's done. So, okay, let me use some online paint. So it's difficult without a whiteboard. So imagine our memory. So memory had some cells where we can store a bytes of information. So earlier, when we had some integer variable, so here we had a value of 5 and some pointer that was called simple. So that's how we stored variables, simple variables. Now, when we have an object, we can store something much more complicated than just one simple variable. We can, let's say, gather some closely connected information and store this inside memory inside one object. So to if we are getting back to this example, we have two variables that describe one particular cat. So earlier we could have two variables that describe one particular cat, but that's not very convenient because if we want to describe cat more detailed, we can add much more variables, and we should contain these variables for each cat we're using. So that's not convenient. Now we can have, let's say, some complicated complicated type that consists of two variables. So let it say be age10 and name Prince. So now we have only one variable that's references here. So for classes, this information inside memory is stored close to each other. Okay, that's just an abstraction. So we have variables that consists of two another variables. So that's a complex. So integer, that's just a simple numbering type. Cat stands here stands for complex data type that may consist of two variables inside, and we can create as much variables of such type in memory as much memory we have. So here it is next variable called Murinch, and here it is. So class, that's only description of so class is a description of objects, of its inner structure. Objects, it is particular let's say regions in our random access memory where actual data is stored. So now, so what can we do with these objects? So just for a start, we have defined two variables here. What can we do here? We can try to access these variables. How do we access them? So we are writing variable name, then we write dot operator. So this dot means access to object's state or behavior. So after a dot, we use variables or functions. We will talk about functions later, just for now. So I put a dot, then control space, and well, here it is our defined variables. So now I can use them. So let's start from name. Okay, now, so that's not a legal construction, just like an unused, just like an variable that's not a statement. Yes, again, not a statement. So that's just a variable. What can we do with this? We can use, we can print it. Name. So that's how we can access some state of an object and use it, for example, for printing. So please rewrite this example, and let's look what we what we have here. So name and null. So do you have the same? So one more new term, one new word for today, null. So what does this null, how can this null be explained? So null, that is not a null or not a zero. So that stands for better to tell nowhere or something not initialized. So let's get back to our picture of memory. For example, we have earlier we had some variable, so that pointed to some cell in memory with an with some data inside. So we could have also some another uh, variable that pointed to some another region of memory, but for example here we had no data, but that's not a case because anyway we have some data in memory cells, at least it can be zeros, so for numeric type that will be a zeros. But null, it's not just an empty cell inside memory. That's just some variable that wants to uh, point somewhere in memory, but it doesn't do. So that's just points to nowhere. So if variable points somewhere in memory, it will contain some value. But if it points to nowhere in memory, so that value is null. So null, it's not an empty value, that's a lack of value, let's say so. So let's look in a debug, what does it mean? Here I have launched a debug, and look, here I have two objects. If I expand this object, I see these two variables, just like here described in a class. So when class, so when we're creating a new object, all the value, every object of this class will contain these two variables inside. And if they are just simply described here without any initialization logic, they will have default values. So int and so other primitive types like int, long, double, boolean, they cannot be null, they can have default value, for example 0. But objects like string, they have this default value of null. So this is the default value for variables that points to nowhere. So now we have just an empty cat without any name, without any age. And what we have done here, we have just printed this his name, but this name is not initialized, so it is just printed null here. But look, we can change it. So let's give our cat a name. So how can we do it? Again, we can access this variable through this dot operator and give a name to a cat. And then let's try to print this once before. For example, name before and name after. So please adjust your code like here, and let's run it once again. Yes, now we had. Yes, we have named our cat. Now let's look on this in a debug. So here, when we try to print this before, uh, the name was not initialized with any value. So we have created object, but it is, let's say, empty. Printed first time. Now we are giving name to this empty object. After this operation, I can see in the debug. Well, we have a cat. Uh, it is a variable name, and look, inside we have variable called name, and now it contains values that we have given here one line before. So now this cat object has its name, and we can use it after. So now it is printed. Now let's give a name to second cat. So Murinch dot name. But please do not use here Latvian letters. So your idea may be confused about it. So better use this English pronunciation. And let's print this second cat name. So here I use another cat variable. Let's try to run it one more time. And look, what we do have here. We have only one class that describes a cat. We can create as much cats as we want. And we can manipulate with them. So we can give each cat its name, but they are living absolutely separately. So if I'm opening a debug, I see I have two different cats. So here it is these numbers that may differ for me and for you. So that's hashes of memory address. So here I see that it's two different objects. And so I have two different objects living in a memory in the same time, and they have different variables, different values. So now I can work with these two cats inside my application. Uh, One more analogy about classes and objects and these cats. So imagine two fanatic cat owners that meet each other, and they are describing their cats to each other. So they are talking about same class. So each of their cats has its name, age, some unique behavior, and so on. But they are talking about one class, about one, let's say, entity in philosophic terms. But each of them has some of its unique objects of these cats. So each of their cats are unique. They are physically different, and they are just objects described here. So now please rewrite these 2 lines of code if it is not done yet. And please say me, is it now understood the difference between class and objects? Well, if it's theoretically clear, uh, please give your uh, please give age to these cats and print it after. So uh, it's better uh, to put these print lines together uh, when you're describing name, next system out print line about age. So for first cat and second cat. So give you 2 minutes to perform it. So give some age to the cats. Uh, do you have here public before int age? No, that should not be private. That should be public. Uh, because usually we have them private. So I just that have written just like every time else. So now they should be public both. Okay, so